In this video, we're going to look at ionic compounds with multivalent metals. So, some metals have more than one possible charge. They are multivalent. So, examples of multivalent metals would be copper as one of them. Copper has two possible charges. It has 2 positive, which is the more common form of copper, and it also has 1 positive, which is the less common form of copper ion. There are 2 types of names, a stock name and a classical name. The stock name for copper 2 is just written as this, copper 2 in Roman numerals in brackets. And then copper 1 positive is just, as you probably have guessed, copper with 1 in brackets. There's also a classical name. The classical name for copper 2 is cupric, and copper 1 is cuprous. As you can see, the Roman numeral in the stock name refers to the charge on the ion. So copper 2 is just copper 2 plus, and copper 1 is copper 1 plus. You'll see in a second how ic and us as suffixes in the classical name apply to multivalent metals. So another metal that we're going to take a look at is iron. Iron has 2 possible charges. Again, the more common one is iron 3. And there's also iron 2. Stock name is very easy to write. We would just write iron 3, and we have to indicate the charge in brackets because it's multivalent, which means that it has multiple possible charges. And using the classical name, the charge that has the higher charge, so like the 3 positive charge, we would say ferric and ferrous for the lower charge. So you probably gathered now that ic has to do with the higher charge, whereas us as a suffix has to do with the lower charge. And the last one that we're going to take a look at, which you see relatively often, is lead. There are 2 possible charges for lead. There's lead 2 positive and lead 4 positive. So the 2 positive in general is more common, and so that's lead 2. And lead 4 positive as a stock name is lead 4. And so this one would be, now it's the lower charge that's more common, plumbus and plumbic. And you'll see that certain periodic tables for the ions will have both the stock name and the classical name listed on the periodic table. Naming with these compounds, or naming compounds with these metals, can be tricky because you need to know which charge the metal has. So, for example, give both possible names for CuCl2. Well, if we take a look at this, we know that we don't know what the charge is on Cu is. Right, we don't know what that charge is, but we know that Cl has a negative charge and that there's 2 of them, right? So whatever charge is on the copper plus 2 times the -1 charge by the zero-sum rule has to equal to 0. And so doing a little mental math indicates that the charge on the copper has to be the positive 2 charge. So that means that the name of this is copper 2 chloride if you're using the stock system, and if you're using the classical system, that would be cupric chloride. All right, take a look at this next one over here. Give both possible names for PbO2. Again, same idea. There is one lead, and there are two oxides, both with the charge of -2, and so that has to equal 0 by the zero-sum rule. So this calculation, or this equation, is going on in your head, ideally, and you're thinking to yourself, okay, so the total negative charge is 4 negative, so that means that the charge on lead has to be 4 positive, or positive 4. So in this case, we would say that this is lead, lead 4 oxide. And if we were using the classical system, plumbic oxide. This next example says, give both possible names of Hg2SO4. Okay. So if we look at this, this is the key thing that we need to remember right here in our calculation, is that we have 2 mercuries. So we have to go 2 times whatever the charge is on mercury plus a -2 from the sulfate, because SO4 has a charge of -2. So you have to think about this. Well, what is the charge on mercury that would lead to this equation equaling to 0? And that would be +1. So we're looking at mercury, 1 sulfate as this name. Alternatively, you can call it mercurous sulfate because it is the lower charge. Excuse me. Mercurous sulfate. Next, give both possible names of Au2CO3. Again, gold has 2 possible charges. We know that CO3 has a charge of -2, and all the positive charges plus all the negative charges must add to equal to 0. So again, I have 2 gold ions. So 2 gold ions multiplied by the charge on gold added to the -2 from the carbonate must equal to 0. So the charge on the gold has to be +1. And so then we say gold 1 carbonate. Alternatively, you can say, I believe it is orous carbonate. Okay, and if this Latin name doesn't appear on your periodic table, you don't need to worry about it. You only use the Latin names that appear on your periodic table. If they're not there, don't worry about it. But this is actually called orous carbonate. Moving on, it says do not use brackets if there's only one possible charge, right? So remember that we're only using this naming system because the metals have 2 possible charges. In this case, like NaNO3, well, sodium only has 1 possible charge, and that's +1, and nitrate has -1. They add to equal to 0. Okay, sodium only having 1 possible charge, I just write sodium nitrate. Okay, same thing over here. This is scandium chromate. Scandium chromate. Only 1 possible charge, so as a result, no brackets. Sometimes you're given the name and must make the formula. This is much easier and is the same procedure that you have been following for other ionic compounds. So iron 3 nitride, That's fairly straightforward because it actually tells us what the charge is, right? So iron 3 positive, nitride 3 negative. Okay, so it looks like I need one of each ion, and the ionic compound is Fe(N). What is the chemical formula for gold 1 bromide? Again, gold would have the 1 positive charge. Bromide has the negative charge, so one of each results in a neutral ionic compound, and AuBr. Copper 2 nitrate, 2 coppers. Nitrate as a complex ion has a charge of -1, so it looks like I'll need 2 nitrates, and you end up with Cu bracket NO3 2. Finally, what is the chemical formula for zinc dihydrogen phosphate? Well, zinc, as you can see, it doesn't have a bracket because zinc only has 1 possible charge. It's 2 positive. And if you look up the dihydrogen phosphate on ion in your complex ion table, dihydrogen phosphate has a charge, I believe, of negative there. So then we have ZnH2PO4 2, and that's your zinc dihydrogen phosphate. Thanks for watching.